Same data. Which one feels bigger? They're the exact same numbers. And this is how bar charts trick you. Your brain compares height. It doesn't check the starting point. The numbers didn't change, the bars didn't change, the axis changed the story. And your brain followed the height. Before you compare height, check where the axis begins. If it doesn't start at 0, your perception changes. Rule number 1. Check the axis first. If the axis can change the story, let's actually calculate the difference. Now that we've seen how the axis can change the story, let's calculate the difference properly. First, read both exact values. Not the height, the numbers. Here, we have 95 and 110. Most people glance at the bars and think, wow, that looks like a big jump. But we don't guess, we measure. Second, subtract the smaller value from the larger one. 110 minus 95. That gives us 15. 15 isn't dramatic, it's precise. Now, if we want percent difference, we divide that difference by the original value. So, 15 divided by 95, then multiply by 100. That shows us the real scale of the change. Common mistakes? Subtracting in the wrong order, estimating from the visual gap, or ignoring the units. Always write the exact numbers first, then calculate, because when you calculate, you're no longer guessing, you're thinking. Now let's move beyond comparing two bars and look at totals and averages. First, totals. When you're asked for a total, you simply add all the bar values together. But remember, never add what you see. Add the exact numbers. Here, we have 80, 120, and 100. 80 plus 120 plus 100 gives us 300. That's the real combined value. Next, averages. An average is the total divided by the number of categories. So if the total is 300 and there are 3 bars, 300 divided by 3 gives us 100. Simple in theory, but easy to get wrong in practice. Common traps? Mixing units, thousands versus millions. Forgetting how many categories there actually are. Or estimating instead of calculating. And one rule always holds. Use the numbers above the bars. Never rely on the visual impression. Because charts can suggest a story, but math confirms it. Now let's take it one step further and look at stacked bar charts. A stacked bar combines multiple segments into a single bar. Each segment represents a subcategory, and the full height of the bar shows the total. So when you compare totals, you add the segments. For category A, that's 60 plus 40, which gives 100. For category B, 50 plus 70, which gives 120. Now you can clearly see which total is larger. But here's where many people make mistakes. They compare the visual heights of segments instead of the actual numbers. For example, category 1 in A is 60, but in B it's only 50. Meanwhile, category 2 in B is 70, larger than the 40 in A. If you only look quickly, you might misread the structure. Another common trap is mistaking the top number for a segment instead of the total. Or assuming the top segment is always the largest contribution. So remember, read the segment values. Add carefully for totals. And never rely purely on appearance. Because stacked charts can layer complexity, but the math underneath is always clear. Even when the numbers are correct, a bar chart can still be misleading. The distortion doesn't come from the data. It comes from the design. One common trick is a non-zero y-axis. If the axis doesn't start at 0, small differences can suddenly look dramatic. Another technique is compressing the y-axis range. When the scale is tight, like 90 to 110, tiny changes appear much larger than they really are. Bar width can also influence perception. Wider bars can feel bigger, even when the values are identical. Color matters too. Bright or contrasting colors draw attention and subtly shift emphasis. And missing grid lines or labels make it harder to judge values accurately. So what's the rule? Trust the numbers above the bars, not the shape of the bars themselves. Because visual design can guide your eyes, but only numbers tell the truth. Now let's talk about one of the most subtle traps in bar charts, units. A bar labeled 150 might not mean 150. It might mean 150,000. Units often appear only once, usually on the y-axis. And if you miss that small word, your answer can be off by a factor of 1,000 or even more. Another common issue is switching units across graphs. One chart might use thousands. Another might use millions. If you don't slow down and check, you'll compare numbers that aren't actually comparable. Decimals can also be deceptive. 2.5 million is not 2,500. And percentages are different from raw counts. 40% is not the same thing as 40 units. So here's the rule. First, locate the unit label. Second, read the exact number on the bar. Third, convert if needed. And only then, calculate. Because in data interpretation, small words matter. And sometimes, the smallest label on the chart changes the entire meaning. Let's pause for a moment and look at what you've built so far. In the first half of this lesson, you've developed 6 essential bar chart skills. You learned how to compare values, using exact numbers, not impressions. You calculated differences instead of guessing from visual gaps. You added totals and computed averages correctly. You broke down stacked bar charts into segments and meaningful totals. You identified misleading designs that distort perception. And you paid attention to units, because small labels can change everything. Together, these skills form the foundation of accurate data interpretation. They apply not just to classroom problems, but to charts you'll encounter in news, business, and everyday decisions. Now it's time to put these skills into action. We're moving from understanding to application. And this is where real thinking begins.
Here is your beginner practice question. The bar chart shows the monthly sales for 3 types of books: fiction, nonfiction, and comics. Your task is to identify which category has the highest sales. Look carefully at the numbers above each bar to compare the values. You will now have 60 seconds of quiet time to solve this question. Take your time and choose the best answer.
Here's the correct answer: comics. Let's look at the exact numbers. Fiction has 80 units, nonfiction has 70, comics has 100. So which category is highest? Comics. Notice something important. You didn't need to estimate. You didn't rely on visual height. You read the numbers. And that's the habit we're building. Bar charts can feel intuitive, but intuition can be wrong. Precision wins. Always read the labels above the bars. Because small visual differences can distort perception. Numbers don't exaggerate. Design sometimes does. And when you train yourself to trust exact values first, you eliminate most common mistakes before they even happen. That's how clear thinking starts.
Now let's move to the next beginner question. This time, we want to compare comics and fiction by finding the percent difference. To solve this question, read the exact values from the chart and compare comics to fiction. Then calculate how much higher comics is using the percent difference formula.
The correct answer is 25%. Let's walk through it carefully. Comics has 100 units. Fiction has 80. First, find the difference. 100 minus 80 equals 20. Now ask yourself, 20 relative to what? This is where many people slip. When a question asks how much higher one value is, you compare it to the original value. Here, we're comparing to fiction. So we divide 20 by 80. That gives us 0.25. Convert to percent. Multiply by 100. 25%. Notice something important. The key isn't subtraction. It's choosing the correct reference value. Percent change always depends on what you compare against. And when you slow down and identify that original value first, the rest becomes mechanical.
Here is your intermediate practice question. You're looking at a stacked bar chart showing sales for Category A and Category B across 4 quarters. Focus on the green segments and identify which quarter has the highest value for Category B.
The correct answer is Q4. Let's focus only on Category B in Q1. Category B is 50 units. In Q2, it increases to 75. In Q3, it drops to 60. And in Q4, it reaches 90. So which quarter has the highest value? Q4. Notice something important. In a stacked bar chart, your eyes are often drawn to the total height. But that's not what the question asks. We are not comparing totals. We're comparing one specific segment. Each colored section must be treated as its own data point. Stacking can visually blend values together, but the numbers remain separate. When reading stacked charts, always isolate the segment first, then compare. That small habit prevents big mistakes.
This is the advanced practice question. Now look at the stacked bar chart showing quarterly sales for Category A and Category B. Your task is to compare their percent growth between consecutive quarters, and decide where the difference between the two growth rates is the greatest. Here are the options.
The correct answer is Q1 to Q2. Let's compare the percent growth of each category between consecutive quarters. From Q1 to Q2, category A moves from 80 to 70. That's a decline of 12.5%. Category B moves from 50 to 75. That's an increase of 50%. The gap between those growth rates is 62.5%. Now compare the other intervals. From Q2 to Q3, both categories move in opposite directions again, but the difference between their growth rates is smaller. From Q3 to Q4, category B increases strongly, while category I declines slightly, but again, the gap is smaller than in Q1 to Q2. So the largest difference in percent growth occurs from Q1 to Q2. Notice something critical. When comparing percent changes, you must compute each growth rate individually. Visual height changes can be deceptive because percent growth depends on the starting value. And in advanced comparisons, the reference point matters more than the direction. Let's step back and look at what you've built. Today, you strengthened your ability to read bar charts accurately and avoid common traps. You compared values using exact numbers, computed differences and percent changes, and interpreted stacked charts by isolating each segment carefully. You examined misleading designs and understood how scales and units can distort perception, and you worked through advanced growth comparisons where the reference point determines the result. Here's the core principle. Always trust the numbers, not the visual impression. Check the scale, check the units, calculate with intention, because real data reasoning is not about guessing quickly. It's about thinking precisely. And when you build that habit, you're not just solving chart problems, you're strengthening how you think.